of course, on our standardized tests have graphs in them, whether they're interpreting graphs or trying to glean data from the graphs to help better answer questions. But even bigger than that, of course, we understand that graphs are everywhere, and it's really important to be able to understand graphs so that the students that we teach can understand the world around them, because we live in a world where there is a lot of data, and sometimes that data isn't always presented accurately. And so it's important that we equip our kids with the ability to understand and kind of make sure they know what's up when it comes to looking at graphs. So before I launch into the rest of the things I'd like to talk about today, excuse me, I do want to acknowledge that we are on Treaty 7 land. Spring feels like it's definitely here. So it's so, I'm always so pleased, happy. I feel so lucky that we live in Alberta, because the weather, it just keeps us guessing. And I do love spring and fall in this province. So the Creator gifted us with this land that we are blessed to share and care for together. The Calgary Catholic School District acknowledges that the land we gather on, Mohkinstsis, is the ancestral territory of the Siksika, the Siksika, the Kainai, the Piikani, and the Anasazi Piikani. We acknowledge all First Nations and First Nation Métis of Treaty 7 lands, the Tsuut'ina, the Ithaqabay, which includes Bearspaw, Chiniki, Goodstoney, and Goodstoney. The Calgary Catholic School District commits to advancing reconciliation guided by truth, respecting treaty laws, and humbly walking alongside First Nation, Métis, and Inuit. We recognize all who live, work, and play on these lands and who now call this place home. So I know we often start with a prayer, but today I thought I actually like to reach into like the depths of the history of our church. And today is actually the Solemnity of the Annunciation, which means we're exactly 9 months before Jesus is born. So we're exactly 9 months before Christmas. So it's a big day, because today's the day the angel told Mary that she's going to have Jesus. It's important that everything that we do is underpinned by our trust, our priorities. And so today, the stuff we'll be working on is tied to our student success priority. Okay, so graphing. I think that graphing is so important, and this is why I think you should too. It is really, graphing's critical for understanding the world around us. It's important for medical information, election information, commercial ads, sports information, all of that. We're inundated with these graphs. Now, here's the thing. When it comes to graphing, there's 2 skills students have to be taught explicitly, and that's how to read, interpret, and analyze a graph, but also how to build and create a graph. And so I kind of I tried to find, well, which should we start with and why? And I dug and tried to find stuff, and this is what I found. Both. We have to start with both, but here's the clincher: at the same time. Yikes, right? I know sometimes we look at the kids in front of us and we think, oh my goodness gracious, how are we going to take something as complex as graphs that help illustrate a phenomena or share information, and we have to both teach them how to read the graph and how to make them kind of at the same time. And so there is no magic bullet. There's no, easy way to do this. But there are some sort of best practices that might help support our endeavor. So there's sort of 6 major ways to approach this. And I'll start with these first 3. The first one is to use data that engages students. I think sometimes what happens is we just make up numbers and we're like, okay, we're going to graph this, and students don't really get why or how, or they're not really invested. Often, data that engages students is stuff that they've collected themselves. So often those inquiry labs that we do, sometimes they even come out of the textbook, can be pretty good if we're measuring reaction time, or if we're measuring how far a ball bounces. Anything that is sort of student generated tends to be better. I mean, not always, but tends to. I think number 2 here is really important. We sometimes forget about it. We have to teach graphing that's grounded in the discipline. So I think what what that really translates for us is that we do a lab for every unit. So we graph chem data, we graph bio data, we graph physics data, we graph geology data, we graph like structural mechanical data. All of that is really in an effort to support that idea that graphs are everywhere and they share important information for all of our important disciplines. So yeah, okay. And here's the third one, and I think we all know this, and I know most teachers do this, but it's always important to sort of refresh our memory. We have to practice explicit instruction. That means providing step-by-step instructions. We have to do it with the students. And I thought this was really fascinating. Much of the research that I looked at, it was really clear that for middle school, high school, and even college, so like university kids, it is really important to have the students do the graph by hand first and then use technology, because sometimes I think what happens is the technology sort of like whips it together. And if a student doesn't have deep understanding of what they've done or why they're doing what they're doing, sometimes misconceptions can be perpetuated. And so having them do it by hand first really is important. And we know this. If you have a student draw a straight line for the y-axis and then a straight line for the x-axis and then mark off every second square, that they build their scale and they understand why we go up by 2s or why we go up by 5s. And that's really important. And the technology piece sort of takes that away because it does it for the student. Okay, so I really like this one. Use real world messy data. I think the research shows that this is important so that it helps students really understand that data is messy, that there's lots of natural variation, and the messiness is important to build conceptual understanding. I kind of put this in as tongue in cheek, but like let math use the friendly numbers. They're the ones that have to do the Cartesian coordinate, negative numbers and positive numbers. But for science, I think where we get lucky is we can use all this data and we can really help students see that nothing in nature is perfect, and that's okay. And in fact, that's really important because it helps us unravel mysteries, in the natural world. Using collaborative work, graphs invite conversation about content and meaning, and then this can't always happen. And I know some students prefer this over other students. Some students probably do prefer working on their own and just kind of building their own graph and answering their own questions. But I think building the building of the graph is really important. But when it comes to do on your own, and obviously with support, but when we come to reading and analyzing, it's kind of a good thing to do together. To help students see what you're looking at and what other students are looking at, and how looking at all these different pieces of the graph help them understand what's happening. And I know many of us do this, as part of a lab or part of any activity that we're doing, but emphasizing reflection. Why did we build the graph? The graph that was built, is it a good graph? Would there be another graph that's better? And of course, part of that reflection piece is drawing conclusions from what you've seen in your graph. So these sort of 6 ideas can and should help support student understanding of graphs. So when we look at interpreting graphs, I just wanted to spend a bit of time unpacking sort of the difference between an emerging or sort of an entry-level type graph versus a mastery graph. And, when we think of our junior high students, we probably have students all along this continuum. So an emerging graph is whereas, when it comes to interpreting a graph, it's just reading data. And it's a very simple, straightforward graph where there's one variable and the domain knowledge is no, so low. They don't need to know a ton about the chemistry or a ton about the bio. They just have to be able to look at the graph and look for one variable. So, in here, it's kind of like this bar graph. Bar graphs tend to be very friendly and approachable for students, as they often will just represent one variable, sorry. Proficient, a student who is proficient at interpreting graphs should be able to read data between points. So if we look at this distance time graph, a student who's proficient at reading should be able to tell me what the distance traveled is at 3.5 minutes or to seconds in this case, or if I said, at about at 5.5, at a distance of 5.5, how long has that, car been traveling? So it's that notion of reading between the lines, I guess. Yeah. Um, and it often represents more than one piece of data, not always, but often. Mastery is extrapolation. It's reading beyond the data, making predictions about what might happen next and what the trend is telling us, what's the trajectory. And mastery graphs, what they have is more than one piece of data. So at the bottom here, I've got the relationship between start temperature and color. I know this comes out of grade 9, but this is a very mastery level graph because there is a lot going on there. There's color, there's surface temperature, there's magnitude. It's a lot, and so this would be very much a mastery level. And to be honest, I would have to really think about how to approach this as a student and even as a teacher. Like, what kind of questions would I ask? What would I want the students to sort of take away from this? On the flip side, or on this, on the other side of the same coin is for constructing graphs. The entry level skill for creating a graph would be probably to start with the bar graph, and it's to look at one variable. It's important not to be confused with a histogram. The reason histograms tend to have more than one piece of data, and they look at things sort of over kind of time. And so if you look at the two bar graphs at the top. The first one with just the one blue graph, that is what I would consider a bar graph. Whereas on the flip side, this is a histogram. It has quite a bit of data on here. And so it would be a lot for a junior high student to build. So bar graphs to start, not histograms. Proficient, students who are proficient at building graphs should be able to build a line graph and maybe provide a line of best fit. They should maybe be able to put together pie graphs or histograms. Now, I think pie graphs and histograms, that's more of a high school skill, but a proficient high school skill. And they might have one variable or they might have multiple variables. Mastery, it's creating a complex graph, like a box and whisker graph with scatter plots. And here it's to illustrate the relationship between multiple variables. So if you look at the age, height, weight analysis graph here, we've got height on the y-axis, age on the x-axis, and what we have is the shape of the size of the circle indicates the weight of the individual. Not only that, it's color coded to sort of determine the difference between genders. So there's a lot of information here. So that would be a really complex graph for a student to build. And so after having built that, they'd also have to have a legend or a very descriptive title and a descriptive a figure legend to help us understand what indeed was happening. So, the best way to support a beginner in all of our students is to have graph paper and to really help students understand that we cannot build a graph without graph paper. Full stop. If we're building a graph, we must have graph paper every time, all the time. It's for our beginner learners, or kind of to back up the scaffold and support our students, providing titles, providing labels of the x-axis and the y-axis, or providing ticks for students to build the scale for the axis is really helpful. The idea would be that as time goes on, we'd remove these strategies. So maybe to start at the beginning of the year, we'd provide the title for the student. We'd cue the student to say, okay, so Y-axis title, and we provide a line. X-axis title, and we provide a line to help cue the students. We put the ticks down, and maybe for some of our students, we'd actually give them the scale just to help them understand that data is on a continuum. Sometimes what I'd find in my science classrooms is as students collected data, they just throw it on, and they would have no concept that they'd have to put it on a scale. So if we were doing, oh, I'm just trying to think off the top of my head here. If we were doing something that that's over time, they would just put time wherever. So they'd put minute 1 at the beginning, and then minute 7, and then they'd go to minute 4, and then minute 3, and I'd be like, oh my gosh, what a mess. Remember, time starts at 1 or starts at 0 and moves forward, and we have to be mindful. Just because you collected the data in a haphazard way, when we graph it, it has to be organized. And sometimes students forget that. I don't know why, they just do, I guess. So I really like these I really like these progressions, and it sort of helps me understand the skills required to develop and the skills needed by the student to access the content at these different levels. So if we look here for reading a graph, so analysis and interpretation, a beginning skill for a student would be that they can locate the important components of the graph: title, axes, legend, and they should be able to understand or at least identify if there's one piece of data or more. So are we looking at just height, or are we looking at height and weight? Is there more than one thing going on here? And this starts to become really important. Just for it's kind of one of those transferable skills. Identifying variables. Is a student able to understand what the independent and dependent variable might be in the graph that they're looking at? Could they identify how the scales are divided? Are they going up by 2s? Are they going up by 5s? Is it by 1s? And they should be able to describe the type of graph. Is it a bar graph? Is it a line graph? And for most of our students, this is kind of where this is the bread and butter of what we do. Really, those are the two types that we really focus on the most in junior high and high school. Proficient, can they identify from the graph where the independent variable is and where the dependent is? Can they describe the trend? Can they read the data along the line? And can they read the data? Can they read data between the data points? And then I think this is an important discussion. Why is it important to do more than one experiment? Just this notion of building having trials just to really help students understand that what they actually are seeing is not just a one-off, but a true phenomenon. Then, of course, mastery is they can draw a conclusion, they can extrapolate data, and they can critique the capabilities and, of course, the limitations of the graph that they have just created, that they're looking at. Like, would there be a better way to show this information? So the second skill that we have to teach at the same time to our middle schoolers, yikes, is construction and design. So building a graph, can they organize the data into a table with X and Y, independent, dependent, or something like that? Do they know they have to do it on graph paper? Like, this is so important. And I just, they have to do everything on graph paper. Can they plot the graph from the table? That starts to be an emerging skill. Can they title their graph? Can they label the axes? Can they build a scale? Can they classify the variables? Like, do they know why they have to do a bar graph? Do they know why it has to be a line graph? Like, understanding the difference between categorical data versus continuous data. And, we tell our students this often: if it has time, it's probably a line graph. Can they draw a line of best fit? And can they, do they understand why they like the best way to build their scales? And so, and I put here plot for mastery, a mastery scale, plotting standard deviation. That becomes more of a high school skill, but it is a high school skill. And so knowing that that's eventually where they need to end up, it's important that we can back it up and start building those skills early in grade, even 6, I think, grade 6 and 7 and moving forward. So I feel like I haven't even taken a breath yet. So a couple of great resources for real world messy data is Data Nuggets and Our World in Data. So I'm going to show you Data Nuggets here really quick. One of the powerful things about Data Nuggets is it's kind of ready to go. Um, so if we go here where it says for educators, oh wow, it's being slow now. It helps us understand how their data is organized. So they have content levels. So they have level 1, 2, 3, and 4. And then they have graph types, which I really appreciate. So they have type A, type B, type C. And so the idea here is that it's scaffolded. And so what you can do is take a look at all of the different themes that this site has. And then you can decide if you want to do a level 1 or a level 2 type graph. And then for each of the graphs that they have, they'll have A, B, and C. So I think that for depending on what you want to do, you can give all the students all types, or you can give them just one. So let's take a quick example. Sorry, excuse me, a quick look. So um, oh, there's so many good ones. See, it's part of the grade 9 curriculum anyway. Okay, so here we go. So Little Butterflies on the Prairie. So you can see here, this is level 2. So if you remember, level 2 is kind of like middle school-ish. And then you've got the student activity, which is graph A, graph B, graph C. And then this is all free. You can just click on it and it's sort of ready to go. And this is what it would look like. So this is graph B. It's a PDF, which is great. And it has the data. And here's graphing papers to the student. So you can see here it's scaffolded. There's the title for the axis, the scale's already built in. And so the student would be expected to plot the data from up here and then answer a series of questions. I think it's just really, it's a really excellent place to start. I feel like, oh, I don't even know where to start. And Our World in Data is it's very good. It's very messy. And there's so much you can look at. And I think the best thing with this is it changes so frequently. It's just to kind of pop on and take a look. So here's a graph, and this one is foreign aid spent domestically. And so what I like about this, it's got a table. And down here, there's a timeline, so we can move the timeline along, and the data will, of course, change. What we can also do is look at the data changed. You can see how the data changes. I think this is pretty powerful because you can show students how the axes change and how, even though the numbers are getting bigger, sometimes the graph looks smaller because we have to accommodate more data. Anyway, it's just a really nice visual. And that is all, my dear friends. So if you have any questions, please reach out. If you have a request for something, also please reach out. I'm really grateful for your time spent with me, and let me stop my recording.